Good? Okay, hi everyone. Hope you're enjoying the conference. My name's Alisha. I'm a software engineer here at Google. I've been working on the gRPC team for over 4 years, primarily on the C++ stack. And today I'll be presenting on gRPC metadata, specifically its uses, some of the nuances involved with metadata, as well as some issues we've recently faced in production because of metadata. And just to note, this talk does focus on the C++ stack. Metadata exists in the other languages, but some of these issues may not have surfaced yet. Okay, so to start, we'll go with a quick definition of what gRPC metadata is. It's a mapping of key value pairs of data that are guaranteed to be sent either before the RPC payload or after. And it usually contains information specific to an RPC. So initial metadata is sent before the payload, and trailing metadata is sent after. So let's first look at the good part of metadata, which is its many uses. So metadata can be very helpful for several different things, including things like auth tokens that you want to send before the RPC. We can also use it for tracing information. So for instance, getting the timestamp at the start of an RPC, or seeing what the duration of an RPC is by taking the difference between when we send the initial metadata and when we receive the trailing metadata. We can also use it for custom headers, so things like why the server rejected an RPC would be in the error information. And finally, other application-specific functionality that would rely on the data being sent before or after the payload. So for instance, we've seen teams send like the version of the application that the request is coming from so that they can process it accordingly. Moving on, we have the bad. So metadata is a very powerful concept, but there are some nuances. And the main issue is that it is not flow controlled. So whatever rate the sender is sending at is the rate that the metadata is going at. And this might be greater than what the receiver can receive at. So if we send a really large amount of metadata, we might end up ooming our receiver. And so gRPC, C++ at least, requires user-defined limits in order to limit the amount of metadata we receive. So we use this channel arg called gRPC arg max metadata size in order to control the amount of metadata that we allow a peer to give us per request. And so if the incoming metadata size exceeds that metadata limit, the request will be rejected. And it's important to note that this only applies per request, not to the whole connection. So for a long time, this single limit approach worked very well, until it didn't recently, where we faced two pretty major issues in production because of the lack of flow control in our metadata. So in the first issue, we had a team come to us with an increase in metadata limit exceeded errors in their client. So usually this just means that the client RPCs are being sent with more metadata than our server can allow. But what was interesting in this case was actually these RPCs did not contain more metadata than the server limit, yet something was throwing some errors. So I'm going to open this up to the audience now to see if anyone wants to guess what could be happening here and why we're still seeing errors. I gave a major hint, so if anyone wants to try. Yes?
There was a proxy.
What about the proxy? Can you take the mic, actually? Thank you.
There was a different metadata size limit on a proxy?
Correct, yes. Tag team, I think, slightly. But yeah, that is what happened in this case, was we did have a proxy that was configured with a lower metadata limit than the server. So the request is not even reaching the server, it was getting rejected by the proxy. And so this can actually also happen if you have a request going from the client, and then the proxy adds more metadata to this request, and then the request gets rejected by the server because it now exceeds the server limit. So we decided here to introduce a global metadata limit for all proxies. This way, clients and servers could easily configure their own limits so that they don't bypass that global limit, and they can make sure that their requests will successfully pass through any proxies. This second issue that we faced was a much larger one. This team was experiencing a full outage where all of a sudden, all of their requests were being rejected. So it turns out what happened was that there was a new metadata element that they just added that was just a few bytes, but it happened to take their total metadata size just over the peers limit. The problem in their case was, unfortunately, they added this element to all requests. So all subsequent requests were now rejected, and this led to a total outage. And we should note that actually this can also happen if you just increase the value of an existing element by a few bytes, and you can hit this cliff. So our solution was twofold. We figured that we needed some more elegant way to fail requests without hitting this kind of cascading failure all at once and causing a large-scale outage. So we introduced two metadata limits to replace a single one, a soft limit and a hard limit. And we can see from the diagram, below the soft limit, all requests are allowed. Above the hard limit, all requests are rejected. But between the soft and hard limit, we have this sort of warning zone where some requests might be rejected and some might not. We increase that chance of rejection based on how close the metadata size is to that hard limit. And we're hoping that by doing this, users will notice that increase in errors before they hit the complete outage. And they can either increase the peer limit or they can reduce their metadata accordingly. So going off of both of these case studies, we have some takeaways here. The first is to make sure that you have consistency in both your soft and hard metadata limits, and to be aware of all of the metadata limits along the path from client to server, including any proxies. The second is to always monitor for an increase in resource exhausted errors. So metadata limit exceeded messages will show up under the resource exhausted status code. You can tell if it's a metadata exceeded error by looking at the error message. We can see here it's actually very informative. We include whether it exceeded the soft or hard limit. We also include what the actual limit is versus the amount of metadata that was received. And we include the keys and the size of the value for each of the keys. So you can also log a successful request with these exact same key value pairs, and you can compare to see why your request is now failing. And finally, we have two channel args now for those two limits. The first is the gRPC arg max metadata size that we originally had, but that's now the soft limit and defaults to 8 kilobytes. The other is the gRPC arg absolute max metadata size, which is our hard limit channel arg and defaults to 16 kilobytes. So that was the end of my presentation. I'm happy to take any questions.
I'll acknowledge that C++ is one of the stacks we don't run gRPC on, so you can definitely just tell me it works in C++. But what we found is with the metadata, it's hard to observe the current metadata size. It's not wired through to the stream tracers, so it's difficult for us to track metrics on it. Is this also something you've run into? Because what we've run into is we get close to the limit and we push over it and we fail in. So obviously this would help us a little bit, but we'd also like to know in advance even before we hit the soft limit.
Yeah, we definitely have plans to add observability for metadata sizes on the path. We currently, I believe, do some debug logging, but we don't have any tracing per se right now. Any other questions? Okay, thank you all for coming. Yes.
Is I maximally far away?
Yes.
And then once I'm done with this, I'll move to the other end of the room. Yes. Yeah. So, are there any plans to add similar functionality for other hard limits, like say, like max message size? Is definitely something where I've seen this blow up, where people complaining about this blowing up.
Currently, I don't think we have plans since this work was inspired by an outage. But should we have an outage, or should we desire to add it and have the resources to do so, I think that would be a good idea.
Hey, this question is trolling a little bit since I was there when you were giving the draft version. Do I need to move to the other side of the room now?
Anything else? Okay, thank you all for coming.